Okay, let's get this party started. I am Chris Hughes. I work for the Energy Conservatory. So a little bit about my background. I am an HVAC technician born and raised. My dad actually is an HVAC technician born and raised. That's what he did after high school and did it his entire life. He's here. He's the guy in the outlaw cowboy hat. Can't miss him. I look like his younger brother. So I've got a deep history of doing HVAC work. I now work for the manufacturer, and I love it. And the reason I love it is because it allows me a lot of free time to work on problems that the industry faces, because I understand the industry's problems very well, because I dealt with them. So a little bit about me, and a little bit kind of segueing into what this presentation's about. So, Adam?
Yeah, I'm Adam Mufich. I'm with National Comfort Institute, NCI. Been with NCI the past, I don't know, a little over 6 months. Prior to that, I had my own residential HVAC company in the Chicagoland suburbs. Actually, I sold it, and the guy that bought it is here today, which is pretty cool.
Did he sit in your presentation?
I don't know if he's here.
What's up with that?
I don't see him. I don't know. That's kind of rude, right?
Yeah.
But yeah, I had, my company was going for 12 years. Prior to that, I worked for a family company my dad owned, and it was one of those situations where I think you were in the same boat, right? Where you work alongside other people, and you're the owner's son, right? So it's like everyone's like, oh, you just get everything easy. But I always had a drive to try to make things better, and that's kind of why I landed with National Comfort Institute, because that's kind of like our whole goal, is to try to bring people up, right? So, and we're going to kind of try to do that and go over inverters today, right?
Yeah, so let's jump into a slide. Let's jump right into this. Who here remembers the good old days, right? Take a thermostat, you turn it down. What happens when we turn the thermostat down? The system cuts on, right? And what happens when it cuts on? We instantly know as a technician that our compressor just went up to 100% run capacity, our indoor fan went up to 100% fan capacity, our outdoor fan's at 100% fan capacity. We are not thinking a second thought about, is this thing ready to be tested, okay? And that comes with confidence. That comes with Johnny Supertech level confidence, right? It's where you're just like, I got this. I'm totally in control of this situation. I don't have to think twice about, is this thing ready to be tested? And that is not necessarily the situation with inverters. So let me ask you a question. How many of you are installing and servicing unitary inverter communicating systems, right? Quite a bit of hands. So another question. Let's talk about the pain a little bit. How many of you service more than one brand, right? Almost all hands should go up for that. We service lots of brands. You're not going to turn down work because they have a different brand of equipment. That'd be crazy. So have you ever been to a job where you don't really know that brand that well, and you're there because maybe it's got a leak or something like that, you're going to fix it, or a situation, and you want to commission it? You want to commission it with, say, third-party tools. You want to put your probes on it. You want to know if this thing is ready to go and put the customer in a good place. Have you ever been to a brand where you're like, ooh, I don't, Chris, he's got his hand up. So tell your story, Chris.
My thing with inverters is the lack of information out there. It's difficult, right? I work on multiple brands. I'll give you an example. I don't do residential, but I just put an inverter in my own home. And when I was commissioning that, I have no idea what I'm doing. But to be fair, when I say I don't know what I'm doing, I don't like reading manuals very much, right? I like watching videos, I like researching information, but I have a hard time with manuals because it's hard to focus on them. And I just have issues, because how do I know that I truly put it in test mode? How do I know that it's doing what I think it's doing? And then my brain is questioning all these things, and I just, I get lost. I get lost in that.
Has anybody had that problem? You're working on an inverter. Okay, I got a hand here, hand here. You're working on an inverter system, and you're thinking to yourself, is this thing really like doing what it needs to do before I test it? Am I really at 100% capacity right now? I don't know.
have you waited long enough? Has it been stabilizing long enough, right? Like,
Well,
do you know, is the blower motor ramped up all the way? Like, how do you know this?
And that's the confusing thing, is the lack of support from manufacturers. It's difficult. Without being a whatever insert name of brand dealer, I'm just a technician going out there to work on something. I want to give the customer the best value, but it's hard to understand.
So that's funny you said the brand, right? You mentioned brand. We actually started preparing for this months ago. And we started doing deep dives on all the different brands, and we were trying to find their data. And it is incredibly hard to find data for different manufacturers, right, that you don't necessarily work on, or you're not. A lot of it's behind like a wall, a password wall or something else like that.
But
right?
some manufacturers then get into what I do every day, which is like commercial, right? And some manufacturers, they just completely gatekeep the information to where you cannot get it. And I'm sure all you guys are thinking of the manufacturer's name right now, but one of the most difficult, but because they have their own technicians, and it's really difficult to work on that. Just had one the other day.
So how would you like to have that information to every brand? Would that be sweet?
That would be.
Okay, well, guess what? I'm just going to give it away. You're going to get that at the end of this. We put all that information together. We've spent months compiling every inverter, unitary system, almost everyone.
We failed on a few, but most of them. And if you guys look at the list at the end, and we're going to give you a link, if you see anything that's missing that you have, please get in contact with us because we'll add it to the list. We want to make sure we share it with everybody.
Right. So we're taking the first big step forward to say, let's put the confidence back into the technician's hands so he has the information he needs to commission that system, because it's super difficult. That's a huge industry problem, and we're going to talk about it. The reason I kind of gave that away is because this presentation is going to let you understand what you need to know through every part of the process so you don't waste time. Because we don't want you to go there, get into commissioning mode, put it there, and then realize, oh, wait a minute, I can't do that right now. I'm not going to give that away because then I'm giving away the presentation. So let's get into it. All right, so let's take a closer look into the differences. So what you see on the screen right now is just like a bar runtime graph, right? Compressor hertz on the left side, runtime going across, and what we see is a single stage system. This is when we had all that confidence.
The
right?
easy
system
one.
goes up, it runs, it shuts down. We know in our brains that system's ready to be commissioned at that level, right? Life was easy. Not super easy, but easy enough. We had confidence.
And then you have the two-stage, which, when did two-stage come out, right? It hasn't been out terribly long, but it's gained a lot of popularity in the past, 15 years, something like that. But that's still relatively easy. Usually you have some kind of an indicator on the indoor board or outdoor board that you're in high stage. And even if you don't know how to kick it into high stage, you could jumper it. It's pretty simple to commission a two-stage system, right?
So manufacturers didn't exactly fail us. They all played the same game. That's what's the important takeaway here. When we went to two-stage, pretty much all played the same game. There was a way to get to two-stage, and it wasn't too terribly hard. But now we're dealing with this, okay? That is the compressor run cycle. It's all over the place. And you have a really hard time trying to find it, where it's at, benchmark it, what's it doing. You don't have any verification. And to make matters just a little bit worse, this is what's really happening. We not only have the compressor that's modulating, we have the indoor fan that's modulating, and we have the outdoor fan that's modulating, and we probably got an EEV that's modulating, right? And all of that is just chasing itself through an algorithm. And what are you there to do? When you're done with your repair, you want to leave that system in its best mode, or it's a new install, you're trying to commission it. So let's think about a car. If you go buy a car, let's say, and you want to get good gas mileage, you see the sticker on the windshield. And so that windshield might say, this car gets 32 miles to the gallon. But then you'd like to know that, right? You drive it and you watch the little thing on the dash. It's like, well, am I getting 32 miles to the gallon? So you're constantly questioning that, right? We do that with cars. But I've noticed since through this research the last months, I've called some of the best technicians in the country. And I've picked their brain. I'm like, hey, how do you know when that compressor is at full speed? They're like, well, I put it in test mode and fan got up there. And I'm like, yeah, but what about the compressor? They're like, I mean, I don't know. Like, we waited in and, it's working. And they're like, I don't really know. And I'm like, well, how do we know?
That's a tough one. I'm thinking back to like the early days when I first installed an inverter, and I remember like taking classes from the supply house. They actually said, you know, just crank down the thermostat, crank it down to 60 degrees and wait 10 minutes, and you're good to go, right? And that's definitely not the case. It's bad information.
Yep, it is. We're going to get into the details of that. So to kick off where we need to start, we're kind of got a checklist. So what you're seeing here is kind of like the spreadsheet from left to right, but in presentation form. And this is the order you should go in. And this is going to be very granular because this is a training, but you can go much faster when you get in the spreadsheet. So Adam, with that, take us into equipment info.
So yeah, equipment info, we're going to start off, you know, you always look at what brands are we working on, right? Because you have to look at what the manufacturer's information that we have, right? And then we're also looking at the line of equipment. We started digging deep into not only inverters from Trane, Carrier, Bosch. We started looking at the different lines. And we noticed differences in commissioning on different lines and different controls, right? So you have certain pieces of equipment like Bosch equipment where you don't necessarily need some type of communicating control. It's a 24-volt thermostat. And yeah, so you just kind of analyze what we're working on. Another big thing is tonnage. We found discrepancies in the same line, the same manufacturer, but different tonnages. So sometimes you have to look at what size equipment. You can't just remember, hey, this is a Trane 20s here. This is my commissioning conditions across the whole line, right? You have to actually analyze what tonnage equipment that you're working on and commissioning.
So who in a million years would have thought that knowing the tonnage is going to matter in your commissioning mode details? You would have thought that all the data for that line would be the same, but it's not.
I thought with inverter equipment, you just put the biggest tonnage and it ramps down.
Oh, that's a whole nother discussion.
So for the people watching virtually who's going to watch this, someone made a remark from the crowd, and he said, hey, just put in the biggest inverter to ramp down. Don't do that. Do not do that.
That's like the biggest, you know, I've heard it said so many times, you can't oversize an inverter. It will ramp down when you need it to, and it'll ramp up to what you need it to. The problem is there's like a bandwidth that it runs within. There's a minimum capacity and there's a maximum capacity. And you want to make sure it's sized properly so you could take advantage of the minimum capacity in part load conditions, right?
All right, so we're using a new inverter brand, and I took the classes first because I want to know the equipment before I go talking to clients about it. The guy's a great instructor, but what I found is we were getting very conflicting information from the guy they're paying to go out and teach us about it. But then when I call in with issues, they're like, well, why didn't you set the fan speed in this dip switch and that? And I'm like, well, because I'm being told that I don't have to. So the guy who's teaching me on the equipment is saying, just put the 2 to 3 ton system in and let it do what it does. It's going to be great. And then the other guy's like, you absolutely can't do that because you're not accounting for the heat load.
So I don't want to go off on too big of a rabbit trail here, but like absolutely you want to be able to take advantage of the minimum capacity. And that's another thing too, like with these controls, as far as airflow goes, I know Brian preaches this all the time, it's airflow before charge, right? ABC. One thing that I found, when you actually start measuring fan airflow with these inverter systems, I was told for years with variable speed blower motors that you just set your dip switch or you set it on the control, you want it for 1200, you set it for 1200 CFM and it's 1200 CFM. It's going to deliver that, right? The problem is with these type of systems is that's a calculated airflow. That's not a measured airflow. So that's like an important nuance is that yes, you could use their dip switches, but it might not be reality. It might not be the correct airflow.
So that's a good segue into the last portion of this part of the checklist is controls. So when you're getting into knowing through the checklist what you need to do, brand, line, tonnage, control. And the controls will vary, right? But we're going to get into that in a minute. So equipment requirements. So I'll take this one. So through our research, we noticed some very, very interesting similarities through all the inverter equipment. And these are some fun ones that maybe get you in the right place when the time is ready. So outdoor temperature. So between 65 and 100 degrees, every brand that we looked into called that a safe range to go into commissioning mode. Some brands even went to 55 and up as high to 120. Now, I put that in yellow to say some brands do that. Now, I would encourage you to go look it up if you can. But if you're working on an inverter brand and you're between 65 and 100, you're probably in a good position to work into commissioning that system. Now, indoor temperature also has limitations. So if you're in the house and let's just say it's 68 degrees, which is probably rare, you know, especially if you're in the South.
In Illinois, that's not very rare.
Maybe not for you. So 73 to 80 degrees. That's the really range we found through all the brands where that's the safe zone. That's where you can commission the system between that. Now, some went down to 70.
Yeah, and let me ask you guys this. How often are you installing new equipment in the middle of the summer and it's warmer than 80 degrees in the house, right?
Every install I've ever done in the summer.
Yeah, down south, that's probably more common than not.
Right. So which means what? You're probably having to go to that job the next day and do a full commissioning. And maybe that should be built into your pricing for that equipment, right? So let's talk a little bit about the wall control or app or display. And this gets a little bit of a nuance because in inverter systems, more than not likely you have the roughly $500 wall controller, right? And the wall controller kind of controls everything, but that's not always the case. Some of these you control with an app. It connects to the wall controller, but the wall controller doesn't do everything for you. It just provides this serial connection to the circuit board on the indoor unit. Or you have brands that are inverter outside and the inside fan just runs, and you have to put in commissioning mode from outside, which is that little device you see at the bottom right. That's a 7-segment LCD display screen with push buttons, and you may be putting it into commissioning mode from the LCD screen, okay? And I believe you'll see that in Bosch. Not to be talking about brands, but I think that's one that's really common.
So you're talking about commissioning and modes and such. Some systems just have charge, right? Your commissioning process is weighing the charge. And obviously you have to check airflow.
Yep, right. And we're going to get to that for sure. Yep. All right. So let's get to commissioning details. Adam, we'll let you take this one.
All right, so here we go. Weigh it in, right? We all know, if you guys read the manual, RTFM, right? If you read the manual, you'll realize most systems, the outdoor unit holds enough charge for 15-foot of line set. A lot of the inverters, if not all of them, actually recommend measuring the line set and weighing it in, right? So that's a important detail, but you always want to verify the charge after you weigh it in. That's a very important step.
Yeah, and you kind of got to look this one up is what Adam's saying. Like, we didn't really we told you 15 foot, but most of them came into 15 foot. I think we found one that was actually said like 25 foot. So a little important detail there. You got to look it up.
Yeah, and there's nuances with that too, because if there's instances where you're using existing line sets, right? And you might not have the exact line set where it was rated for, but you have a line set that will work based on the installation manual. So you have a little bit of a discrepancy in line set size.
So fun fact, that data point's on our spreadsheet. So you may not have to go look it up. Okay, charging method.
So yeah, I think everyone here, you guys all have like a hunger for knowledge. You guys love what you do, right? There's a reason why we all traveled to Florida for the HVAC symposium. So I'm fairly confident most of you guys know what superheat and subcooling is and how to measure that, right? If you need a little bit of a refresher, Ty Branneman's the man. He has tons of videos online. It's awesome. If you want to dig in deep.
Yeah, I was going to say, if you're new to the industry and you're here because you're super inspired, maybe you should get formal training.
Yeah,
That's what Adam does.
Come and talk to me after the fact. We have refrigerant classes. NCI has refrigerant classes that very beneficial to that.
Yep. So we got to know.
Back to your point about measuring the line set. So something that came up, the difference between people that dabble in refrigeration and then get into air conditioning. Are we talking total equivalent length, or are we talking measured length when it's talking to measuring for the refrigerant charge? Well, I think, and the reason why I brought that up was just to make a point.
Yeah, no. I think in most cases, it's going to be measured, right? And I think the total equivalent length is more of like a pressure drop type of deal that you're worried about.
Exactly,
right?
but I think that kind of making the point that a lot of manufacturers aren't making this easy for people is them not telling us that, we need to look at total equivalent. Because if there's anybody that has any refrigeration experience, when I was installing it at my house, that's the question that came to my head. When it says 50 foot, this much refrigerant, then it's like, well, is that, oh, but then you start thinking about it, and it's like, well, they're talking about liquid volume inside of that. So
when you're looking at a manual and when you're trying to decipher between equivalent length or measured length, like in the venting tables, if you're on a condensing furnace, they're going to tell you that this fitting equals this many feet, and they're going to want you to talk about equivalent length in that part.
but I would say that's also when you're talking about the furnace, but we're talking about the liquid line.
Well, that's correct, but they specify in the furnace because that's what they want you to look at. They don't specify in the manual when they're talking about refrigerant lines because they want the measured length. They say this many ounces per foot or per 5 feet.
Yep. I think the point is there's tons of gaps in information in the installation manual, right?
Yeah.
There's information that's missing.
For sure. Okay, on to our next one. So, talking about data collection and trying to let you know what's on the spreadsheet, we did find that the subcooling target was 8 to 10, pretty much on average.
In most cases.
All brands. And you had an interesting point on this.
Yeah, so the funny thing is, if you guys are working, somebody yell this out to me. If you guys are working on traditional, a traditional TXV system, what is the charge tolerance? What do you normally see? If you have a target 10 degrees subcooling, what do you normally see? Plus or minus 3 degrees, right? What we found is in a lot of cases, you'll have plus or minus 1 in inverters. Sometimes it's different. Sometimes they'll give you plus or minus 3. So that's always a factor that you want to look into. And if you've tried charging something with plus or minus 1, it takes a lot more time and a lot more dialing in than just trying to get it close with plus or minus 3.
Mm-hmm. Yep. And the dreaded wait time. Okay? So let's talk about that for a second. When we were back in the good old days, we'd turn a thermostat down, the system would run, and, we would, in my climate, we'd wait 5 minutes, maybe 10 minutes tops, and we just go straight to commissioning, right? We check airflow, we check charge, we're good to go, let's get down the road. That is not the case with inverter systems. More than likely, almost every brand you touch, you're going to have to wait 20 minutes. Those algorithms in the circuit boards are going to take their time, and they're going to pulse up, and pulse up as they go. And a lot of that is they're trying to protect the compressor, right? They're working their way up, they're chasing a target, and so it takes time. So 20 minutes is pretty much the common knowledge there of like the wait time you're going to need to wait before you even start to check the subcooling.
Yeah, I would say the one caveat to that is if you're using like some type of app like MeasureQuick, you might be able to work around that and cut it down a little bit if the smart probes are telling you that the system is stabilized before that 20-minute period, right? Because that's looking at a bunch of different data points.
Yep. So that's the 4 steps. That's the four important pieces of information for our commissioning details. All right, startup instructions. Accessing charge mode, right? That's probably what you came here for. So, like we talked about earlier, we want to get the outdoor unit to 100%. We want to get the indoor fan to 100%. And we're going to do that either from the app, the thermostat, or the display screen outside on the outdoor unit. And how many times have you been told to consult the OEM? I mean, I think I see Brian Orrin in here, right? RTFM.
Yeah.
That's what he's going to tell you. So let's talk about that. So this is what our research found, and I just want to share a couple of these slides with you. So let's look at a few of these manuals. Here's a manufacturer it's a snippet of their commissioning mode details. Now, I don't know about you, but if you take the time to read that, and we don't have to read it all the way right now, but that's a little bit confusing and a little bit vague. Right? That's like, okay, well, I don't really, I'm a technician. Give me some plain language here. This is weird to me. Right? How about this one? When conditions are favorable, you're good to go.
Yeah, what's favorable?
Hey, Adam, I want you to commission that system. The conditions are favorable. Go for it. What does favorable exactly mean? Right? You give me all these statistics, outdoor range, indoor temperature range, great, but like, okay, when conditions are favorable. How about this one? You could look at the hertz, like we talked about. Now, why does the hertz to the compressor live in the sound profile of the piece of machinery? Why do I need to go look up sound data to be able to find the Hertz wave, so I could try to figure out where I need to go find how to use that Hertz wave to know that it's ramped up all the way. That's a weird place for that piece of information to live. That's where it's at. And this one's probably my favorite. This unit, it actually has a way to put it in commissioning mode and verify it, but I have to go outside. So if I'm working inside, how do I know when it kicks out of commissioning mode, right? So if I'm doing airflow verification, do I check the airflow and then run outside and go, oh, we're still there? I could trust that.
You got to have your
right?
help. You need a helper.
You need a helper, right? You're on the phone. So that's a little unfair. That's a disadvantage. So what we're kind of saying is the manuals are tricky. We need help, right? And what we need manufacturers of equipment to help service technicians. We need to play the same game. This happened in commercial. My old man in the outlaw hat, he lived it. You want to go see how that game played out a long time ago. Ask him about it. But in residential, we're starting to see a lot of the same controls come into residential equipment that was in commercial equipment. Commercially, they had this problem, and they fixed it. They normalized it, had a plan.
Well, I think another thing, too, is not only normalizing it, give the data. Be free with the data and put it out there for everybody. If you're a Carrier dealer, you should have access to Trane. If you're Trane, you should have access to Bosch.
Yep.
Everything should be out there.
We're after one big goal. We want to get these systems running properly. That way we can commission systems properly and get the most out of them, right? That's what's best for the planet. And that's our job. And it's getting a little difficult with inverters, but we can get there. So this is our first foot forward to that. So this QR code will take you to the spreadsheet that we've put together. Okay? And this is just an app that I kind of put together for TEC. And what this will do is it'll take you to just a quick little link to a Google Sheet, right? This is very rudimentary here, but we got to start somewhere. And you'll find it in TC support, HVAC support, inverter checklist. That'll take you to the Google spreadsheet. And everything you've seen us talk about and cover, it'll just be in order across the sheet.
And if there's anything missing in here, I mean, we worked hard. We've met, how many times did we meet?
For about 4 to 6 months, every Friday we had a meeting to try to compile this data.
Yeah.
It doesn't look like a ton of data, but I'll tell you, those startup instructions, man. And I'll tell you, let's get into this. You see these guys right here? I don't know if any of them are in here, but if they are, they should stand up. All right, they all went to a better class.
Yeah. The only one that we missed
one of them's here. One of them's here. So,
we had Ted Cook is the only one that's not on here. If you guys, anti-DIY HVAC, he helped us out as well.
So these guys helped us in one way, shape, and form to pull this data together, to help us get this spreadsheet off the ground. Because as we showed you with the commissioning instructions, it's not all there. So you got to go find it in different places. Like you were telling me about the equipment where you had startup instructions.
Oh, yeah. I'm not going to mention a brand name, but I was a dealer. And actually, the first time I ever worked on this specific line of equipment, right, we installed it, and I was reading the installation manual. And I actually did my homework because this is a fairly complex piece of HVAC, right? And I read the manual. When it came time to start up this heat pump, it was cold outside and they needed heat, and it was not working. Nothing would start, and I'm like, what the heck is going on? I actually called and bugged. I don't know if you guys know Roman from Kalos and HVAC school and that, but I called Roman, and I think I irritated him because it was right after he had a baby. I'm like, dude, I need your help. We have no heat right now. I just finished this up. It's late in the day. I found out you need the service manual, not only besides the installation manual, and the service manual doesn't come with the equipment. So then I had to download the service manual and read that because I didn't know how to commission it. It wasn't provided with the machine.
Yeah. So the data's not being sent out with the machinery to read and do it on site. We've got a comment in the back right there.
I've got a question for you. So when you guys are talking about commissioning what details are you looking for specifically in terms of inverter from the design side to commission against? So like, for example, you're talking two-stage or single-stage, like usually on the design side, we're providing external static pressure that we design to, dip switch settings, airflow, that type of thing. So like with these inverters, it's a bit of different information, I think, that the designer has to provide the guy that's commissioning it to be able to get to the point where you're actually finding out if the system is performing to your design or not.
That's a great ad.
I think a lot of that goes into, too, just like what I said earlier, like talking about airflow and calculated airflow versus measured airflow, right? That's a big deal. And I found one of the most expensive heat pumps that you could possibly buy, over $10,000, ground source heat pump. I set it to commission the heat pump, and we were like 250 CFM off of what the calculated CFM was, right? So to your point, I think you need to actually measure it on site. Another thing that I found is certain blower motors don't play nice with static pressures that are outside of a certain range. And I ran into one where we had too low of static pressure. And, I called in, and the first thing the tech support guy told me from this manufacturer is, I'm having this issue. He said, your static pressure is too high. I said, my static pressure is 0.3. And he's like, okay, it's too low. I'm like, which is it? Is it too high or too low? So there's like a range a lot of times you have to be within. And I know there's like some algorithms based on static pressure in that. And I know Chris Mahaly, he's the motor guy. He could probably talk to you guys a little bit more about like that static pressure range and the programming in the blower motors, right? But you're not going to have the correct sensible and latent capacity if you don't set up your airflow properly. And if you don't have the correct airflow, you're not going to charge it correctly.
And I just want to add, Jeremy, you're speaking, your comment is, you're saying, I am the designer. I give you the airflow. I give you the static. When you commission my system, I want you to commission it at that airflow, at that static.
Right.
That's what I'm shooting for, because I want to match the design.
Right, because that's the calculated BTUs we're trying to deliver. So
Right.
As a commissioning guy, when you get out there, is it better for you to have just the airflow and the static, and then you're saying you measure it on site and you're going to know what to do from a commissioning standpoint to get it to wherever you need it to go for that design airflow?
So I think we're talking two different games here. If you're a service technician and you don't have the design of the home, right, which is probably going to be common, you would like to at least be able to put it in charge mode. You could test it. If it's high static, you could lower it. You're going to lower the capacity, but you're going to get the system into a workable state. On the flip side, if it's a brand new system and you get a design, say from someone like Jeremy, then Jeremy is going to want you to commission it in that airflow and that static. And you're getting into the more of the stats, set the airflow, right?
Yeah.
Set the airflow of that inverter.
And the rules of thumb for CFM per ton, that's kind of geared around service techs, right? Because a lot of times we're working in 30, 40-year-old houses or whatnot, and there probably was never a design in the first place. So we look at climate, right? We have a hot and humid climate. We're looking at probably 350 CFM per ton, give or take a little bit. You have a little bit of wiggle room. Midwest, we're 400. And, dry climate like you're 450, 500, right? So, like, you're all over the board. But if you're working on a new construction or actually design build type of job and they tell you what the airflow should be, don't use the rules of thumb. Dial it into what the designer is telling you to do so you match the sensible and latent requirement.
So just want to make sure we get all the way through this. But we're going to have a little time for Q&A, so hang tight. So one last little tidbit to this slide deck before we open up for a little bit of Q&A. Even though you get it in charge mode or test mode, whatever you want to call it, you get it ramped up. The one thing we really need as well is verification. How do I know that the system is at what I told it to do? That's what we need. We need that data as well. That data is increasingly hard to find, way beyond the startup instructions. And I'm going to tell you, we don't have it. And the reason we don't have it is because when we come through those manuals, we didn't find it. That's our big complaint. And we need it. So there is a little bit of help here, though. And Adam's going to kind of tell you what you should be looking for if you go down this road. You're going to find yourself one day on a problematic job. And you're going to think, man, I have to know how to verify that this thing's doing what I need it to do. And there's a way to do it. You're going to have to really get with your manufacturer of equipment and ask them for this information. But what you're looking for, remember those waves that we were looking for, compressor run cycle waves? The Hertz wave, the RPMs, RPS, whatever they want to call it, whatever you're looking for, they're going to provide that data some way, shape, and form. You can go collect that data.
Yeah, actually, one piece of equipment, Bosch, when you go into commissioning mode, it tells you what the Hertz is, right? And
right.
The 7-segment display, so it's really nice. But as far as we know, that's pretty much the only way to figure this out, is if you pay attention and get the data from the manufacturer, if they'll even provide it.
Now, fair statement here, because there's probably people here who work for the equipment manufacturers. Help us. We're just two guys who worked on this for months, right? And we're pretty smart, at HVAC. I wouldn't say other things, but
maybe you.
I'm a pretty good husband, But HVAC, we're really good at it, and we spent months to get to this point. Could we use some help? Yeah, and we'll do the work, and maybe y'all can help us. And we can turn the tide. And we can go back to that beginning where we all have that same level of confidence, right? So, a little bit of Q&A. All right, so we got about, let's just say 5 minutes or so. So we could take like 2 or 3 questions if anybody's got any.
I wanted to share a quick issue that I ran into, and I'm hoping to start a conversation with somebody who hears this and is like, I got to talk to this guy. So I went to a nightmare project where this client had already had 12 other service companies come to his home and try to find an issue. And I love that because I'm like, great, I'm going to be your guy moving forward. I'm going to find this problem.
The hero.
Exactly. So anyways, am I allowed to name drop brands? Can we do that?
Let's leave it out. Let's leave it out.
So this brand I was unfamiliar with because I don't see a lot of them in my region. But when I called to get some help on this thing, it's an HRV. So it's got a double stacked outdoor unit that goes to a branch box that feeds 2 separate air handlers that are separately ducted. Okay, it was very foreign to me, but I was still there for the fight. I'm going to figure this out. What I didn't care for was the experience that I had with their tech support, if you will. Can I name drop the guy?
Oh, no.
I hate him. I hate him so much. Anyway, so this guy...
You can, just not with the mic.
Gotcha. I didn't like the experience, but what was interesting was this guy that did this to me, there were 2 of them with the same exact name. So when I called to complain about the guy, they were like, which one? But anyways, what it got down to, though, was I had to buy a USB and hook it up to my laptop and then hook it up to this device. And it was good because, the first guy didn't want to help, was very rude, not cool. Next guy, he was like, let me jump onto your laptop with you. Took over the whole thing. I mean, he was so great. He was fantastic. It was night and day with the 2 experiences that I had, but it was daunting, and it took me 3+ hours just to get somebody on the phone.
So let me ask you questions. I think I know the world you're talking about a little bit. So I did quite a bit of commercial work where there was one outdoor unit that connected to multiple indoor units, right? So did this system have more than one line set leaving from it, or did it have a main and it went to the branch selector box?
3 lines went to the branch box, the selector box.
Okay, so that's what you're dealing with is pretty much commercial equipment.
In a residential home.
In a residential home, which we're starting to see this a little bit more too. And that level of equipment will not be on the spreadsheet for one thing. That is very, very specialized equipment and equipment training. That is typically you'll go to the manufacturer, you'll sit in 2 classes. They'll have an installation and a service class, and you'll have to take both to even put that equipment in. I don't know if all the equipment manufacturers are doing that, but when I did it, it was required before you could buy the equipment that you go through both of those classes. But getting in your computer, that level of equipment, there's a lot of data that you can see, and you have to hook your laptop up to it, and you're not really dealing with superheat, subcoolant, kind of a different game. You're dealing everything from the computer, right? And that is the VRV, VRF market is what you're talking about.
And kind of to touch on your point too, we were talking about gatekeeping as far as the installation manuals go. Have you guys ever tried calling tech support for a brand that you are not a dealer for? and they just don't want to talk to you, and they're just like, oh, you're not a dealer? I mean, that's super frustrating because you're like, well, what do I do? I'm here, like, I got to fix this thing, but they don't want to help you if you're not one of their dealers. It's crazy.
We've got one more question here, I think, and then I think we're going to probably be out of time.
So what's the future of the list? Are you going to maintain it?
That's a great question. I'll tell you, some people told me I shouldn't do the list, who were kind of like, ooh, Chris, you do that list, you're going to have to maintain that list. And I'm like, okay, well, that's a really hard thing for me because I've never been on the manufacturer side, and now I am. And so I've had this tear inside of me of like, what do I do? Like, I came here to make a difference. Do I do what more manufacturers do, and I put up my wall and say, oh, well, I can give you that because you called, you asked, blah, blah, blah? Or do we change the tide, and do we become, do we do the right thing? Do we say we share the data? And there may be a mistake that I didn't capture perfectly. But right now, we have nothing. And so this is something. And so I'll do my best with the time I'm allowed to work on the spreadsheet. It's there. I'll maintain it. My hope is that we just kind of become a thorn, right? And then eventually the equipment manufacturers go, you know what? We should just make this all public. And the only way that's going to happen is if, the only way any of this ever happens is if collectively all of the technicians of the world rally together and ask for it. And if you do that, you'll get it. But until we all just play our own separate game and ask and don't rally, we're not going to get it. And I'm starting that rally. That is kind of the point right now.
And if you guys, once again, if you see anything that's missing on the list, send it to us. Get in contact with us because we'll happily, we'll be happy to add it. Like, we want to keep this thing as relevant as possible. So help us, please.
Yep. That's it, guys. Thanks.
Thank you, Mr. Chris and Adam. Thank you.
Thanks for watching. If you're willing, give this video a thumbs up and drop us a comment. Don't forget to hit that bell icon to stay updated with all of our future videos. And as a quick reminder, HVAC School isn't just a YouTube channel. Dive deeper with us at our main website, hvacrschool.com. Curious for more knowledge on the go? We've got you covered. Tune into the HVAC School podcast, available on all your favorite podcast apps. And while you're at it, join our thriving Facebook group. Also, don't miss out on our free mobile applications available for both iPhone and Android. We're all about community. For techs, by techs.